Alright. Hey guys, welcome back to our stream. And so for today's video, I am very interested to discuss something interesting and at the same time knowledgeable for you guys. And for today's stream, it is kind of special because I am not the only one who's going to discuss something for you today. Because I have my classmate here to help me spread something interesting and at the same time knowledgeable for you guys.
Hey Lance, thank you for inviting us today. Of course, we are here to help you discuss
Hey guys, thank you for joining me today. So guys, how are you doing in this time of pandemic? I hope you are all doing alright because it's so hard to cope up with stress in schoolworks and in life. So, are you ready to help me discuss something interesting for our viewers today? Okay, for today's stream, we are going to dig deeper about, can you guess it guys? What is the topic that we are going to talk about? Can you guess it? Okay, you guessed it. We are going to talk about soil chemistry. Most of the time, we often take it for granted every time that we found delicious fruits or vegetables in market or in our fridge. However, did you stop and think about where are all this food came from or what happens in the soil when food is produced? Today, we are going to find that out. But first, let me define what is soil. Soil is a loose material that covers the Earth's surface in the most part of the world, and land is covered by soil. You can think of soil as the living skin of the earth. Soil also provides nutrients for plants for them to live and grow. Soil is a major source of nutrients needed by plants for growth. The three main nutrients are, we have nitrogen, we have phosphorus, and lastly we have potassium. That is why it is very important for us humans to protect and preserve our environment, most especially the soil. Because if we continue doing our wrong habit, which is poisoning our soil, its effect will bounce back to us humans. Because if the soil that we have is poisonous or is not an ideal to plant on, paano tayo makakapagtanim? Because we humans and also the animals, we cannot produce our own food. Only the plants can produce their own food. And kung yung soil na meron tayo is hindi siya pwedeng pagtaniman, then paano tayo makakapagtanim? And if hindi tayo makakapagtanim, paano tayo makakakain? That is why we need to educate ourselves and at the same time, magkaroon tayo dapat ng self-discipline. On the other hand, there are things that we should be aware of because we only had limited amount of arable soil. In fact, only about 3% of the Earth's surface is considered as arable soil. The rest is consists of water, cities, swamps, deserts, and mountains. Nonetheless, soil is not just a dirt because it is an important natural resources on our planet that provides the foundation for the 7 billion life on Earth. On a final note, soil is essential for life. Soil is an ecosystem in which millions of living creatures live and interact. That is why, as humans, it is very important for us to remind ourselves why we are here. We are here to protect and preserve God's creature so that the next generation may feel and see the beauty of our home called Earth. So next, let Emil Torres discuss the main objective or the main discussion for today, which is the soil chemistry.
I'm here to discuss the soil chemistry. But first, what is soil chemistry? It is a study of chemical characteristics of soil, affected by mineral composition, organic matter, and environmental factors. Also, it is the branch of soil science that deals with the chemical composition, chemical properties, and chemical reaction of soil. Involve the chemical reaction in soil that affect plant growth and plant nutrient, and process between the components, and particularly focus on investigating the fate of contaminant in the subsurface and surface, and also the nutrient of soil. To understanding of the chemistry and mineralogy of inorganic and organic soil component is necessary to comprehend the area of chemical reaction that contaminants may undergo in the soil environment. Soil chemistry is concerned with the chemical reaction and process involving these phases. For example, Carbon dioxide in the air combined with water acts to weather the inorganic solid-phase chemical reaction between the soil solid and the soil solution influence both plant growth and water equality. Soil are heterogeneous mixtures of air, water, and inorganic solid and microorganisms. But first, what is the importance of soil? Soil is essential for life. It is an ecosystem in which millions of living creatures live and interact. It is also important to the farmers in planting their crops, vegetables, and especially rice. Also in building infrastructure. So now let's Paulo Tolosa discuss the soil matters.
Thank you, John Emil Torres. Today, I am Paulo Tolosa and we will be discussing soil matters. So, first of all, what is soil? Soil is the unconsolidated mineral or organic material on the immediate surface of the earth that serves as a natural medium for the growth of land plants. So, as you guys know, soil is everywhere, like almost everywhere. We need soil in order to, make our plants grow. So, in solid, organic matter is quantitatively a minor fraction of soil. Inorganic solid phases in soils can generally be described as minerals. In soils, rock provides the raw, like, soil. It contains rocks, and rocks are minerals. So, minerals may derive directly from rocks with little or no chemical or structural changes, although physical changes, like, usually from lavas and such more. Air. Pore space is that part of that bulk volume that is not occupied by either mineral or organic matter, but is open space occupied by either air or water. Ideally, the total pore space should be about half of the soil volume. So it means the air space is needed to supply oxygen to plant roots and soil organisms. Pore space also allows the movement and storage of water and dissolved nutrients. Next is water. Soil moisture, also known as water content, is the quantity of water contained in soil. Soil moisture or soil water is important as it serves as a carrier of plant nutrients. So, without water, plants won't be able to survive. To regulate soil temperature, those is microbial activity and many more crucial activities that are essential for plant growth. So that's pretty much it, the three phases of soil. So field capacity is the amount of soil moisture or water content held in the soil after excess water has drained away and the rate of downward movement has decreased. This usually takes place 2 to 3 days after rain or irrigation in previous soil of uniform structure and texture. Furthermore, let's call on Vincent Sarmiento to discuss soil color. Vincent?
What do you mean by soil color? Soil color tell us stories on how the soil is formed. The first impression we have when looking at bare earth or soil is color is up. Bright colors especially catch our eye and soil can vary with ecosystem. The story of soil color tell us vary with the ecosystem in which the soil formed and are influenced by parent, material and some other factors. Soil come in different shades. Most shades of soil are black, brown, red, gray, and white. Now, let's discuss the different types of soil color. Let me begin in clear or white soil color. They may be white from which they may be influenced by calcium and magnesium, carbonates, gypsum, or other more soluble salts. Often a white layers, mostly quartz, occurs between organic matters on the surface where pigments were removed will consist state soil. Secondly, the brown soil color. Brown soil might be brown from decaying plant material. The darker color often indicates undecomposed organic matter, known as humus. Soil has living organism and dead organic matter which decompose into black humus. The third one, yellow or red soil colors. Yellow or red soil indicates the presence of oxide, ferrous iron oxides. The red color might be mainly due to ferrous oxides occurring as a thin coatings on the soil particles, while the iron oxides occurs as a hematite or a hydrous ferrous oxide. The color is red, and when it occurs in the hematite form as limonite, the soil gets a yellow color. And lastly, gray soil colors. Organic matter plays an indirect but crucial role in the removal of iron and manganese pigments in wet soil. All bacteria, including those that reduce iron and manganese, must have a food source. Therefore, anaerobic bacteria thrive in concentrations of organic matter, particularly in dead roots. That's the soil colors. And now let's move on the soil layers to be discussed by Harold Tongio and Joash Cruz.
Hello guys, I'm Joash Hernandez Cruz, and I'm going to discuss the soil layer. Soil is made up of distinct layers, called horizon. They range from rich, organic upper layers to underlying rocky layers. There are different types of soil layers, and each of them has its own characteristics. And first, I am going to discuss the O horizon first. The O horizon is the top of all layers, and this is where we stand. This is the organic layer of soil, and it is made up mostly of leaf litter and humus, or which we call decomposed organic matter. The second layer is the A horizon. This layer is called the topsoil. It is found below the O horizon. Mostly minerals from parent material with organic matter incorporated. This is where the seeds germinate and plants' roots grow. It is a good material for plants and other organisms to live. It is rich in minerals and humus because it is made up of decomposed organic matter mixed with mineral particles. The third layer is the E horizon. This alluviation layer is light in color. This layer is beneath the A horizon and above the B horizon. It is made up mostly of sand and silt, having lost most of its minerals and clay as water drips through the soil in the process of alluviation. And here is Harold Tongyo for the next layers.
Next up, we have the B horizon, or known as subsoil. It is a layer of soil under the topsoil on the surface of the ground. Like topsoil, it is composed of a variable mixture of small particles such as sand, silt, and clay, but with a much lower percentage of organic matter and humus. Subsoil can offer valuable nutrients and water for plant growth. Recent research has shown that, although nutrient availability to crops can vary, subsoil can contain a large share of the total nitrogen and phosphorus contained in the soil and retain water under drought conditions. Next up is the B horizon. Let's say after the B horizon, we have the C horizon, or for what we call the parent rock. Parent rock, also referred to as substratum, refers to the original rock from which something else was formed. It is mainly used in the context of soil formation, where the parent rock or the parent material normally has a large influence on the nature of the resulting soil. For example, clay soil is derived from shale, while sandy soil comes from the weathering of sandstones. The term is also used in the context of metamorphic rocks, where again, the parent rock or potholite refers to the original rock before metamorphism takes place. Parent rock can be sedimentary, igneous, or metamorphic. So for short, This layer contains much of the material that the soil was originally made from. It will contain rock fragments. Weathering breaks down the parent rock into smaller and smaller pieces of rock, and this layer is most often light in color. And last is the R horizon, or the bedrock. It is a massive rock such as the granite, basalt, or quartzite, limestone or sandstone, that form the parent material for some soil. Bedrock can extend hundreds of meters below the surface of the earth, towards the base of the earth's crust. The upper boundary of bedrock is called its rockhead, or called rockhead. Above the rockhead, bedrock may be overlain with saprolite. Saprolite is the bedrock that has gone under or undergone intense weathering or wearing away. Saprolite has actually undergone the process of chemical weathering. This means saprolite is not just less consolidated bedrock. It has a different chemical composition. Flowing water or ice has interacted with minerals in the bedrock to change its chemical makeup. Above the saprolite may be layers of soil, sand, or sediment. These are usually often younger and unconsolidated rocks. Exposed bedrock can be seen on mountain tops, along rocky coastlines, in stone quarries, and on plateaus. Often, these visible exposures of bedrock are called outcroppings or outcrops. Outcrops can expose through natural process such as erosion or tectonic uplift. Outcrops can also be reached through deliberate drilling. Okay, so moving forward to Ian Torres to discuss the soil texture triangle.
First of all, what is soil texture? Soil texture refers to the proportion of sand, silt, and clay-sized particles that make up the soil. So, why texture is important to the soil? Because it influences the following. The first one is the amount of water that soil can hold, and the second one is the rate of water movement through the soil, and the third one is how workable and how fertile the soil is. Now, let's go to the very complicated looking triangle. It is called the soil texture triangle. So looking at the triangle, it looks so complicated, but trust me, it wasn't. It was so simple. So the first thing you must do is to get the percentages of sand, silt, and clay. So how will you do it? For example, you made your own mason jar soil test, and you get these numbers. So how will you reflect these numbers on this soil texture triangle? So let's start in the clay side, but it depends on you where you want to start. So we have 25% of clay. On the clay side, we should remember that we should always draw a horizontal line. Next one is the silt percentage. So we have 25% for silt, and we should remember here that we should draw a downward line on a diagonal path. On the bottom side, we have 50% for sand. So we should remember here that we should always draw a line upward on a diagonal path. So after reflecting the numbers we get from the sample jar soil test, we should take a look now where they intersect. So they intersect inside the piece of graph of sandy clay loam. So we can safely say that the type of soil in the sample soil test ends up being sandy clay loam. So now let's proceed to the soil texture to be discussed by Melvin, Toledo, and Vargas.
Next, we have soil structure. Soil structure is defined by the way individual particles of sand, silt, and clay are assembled. Single particles, when assembled, appear as larger particles. These are called aggregates. In short, we have soil structure is the arrangement of the sand, silt, and clay particles in the soil. We have different types of soil structure. First is granular, prismatic, water circulation, and it is commonly found in forest soils, in part of the A horizon, and in clay-like soils. Next, we have prismatic. In prismatic structure, the individual units are bounded by flat to rounded vertical faces. Units are distinctly longer vertically, and the faces are typically cast or molds of adjoining units. Vertices are angular or sub-rounded. The tops of the prism are somewhat indistinct and normally flat. Ito sa prismatic, soil particles ay yung mga soil particles na buo into vertical columns or pillars. Tapos, nakikita sila sa big horizon kung saan nakikita yung mga clay. Next, we have Mark Vargas to continue the discussion about soil structures.
Hi, I'm Mark Vargas. The next structure is columnar structure. In columnar structure, the units are similar to prisms and are bounded by flat or slightly rounded vertical faces. The top of columns, in contrast to those of prisms, are very distinct and normally rounded. Columnar structure is common in the subsoil of sodium-affected soil. Columnar structure is very dense and it's very difficult for plant roots to penetrate these layers. Techniques such as deep plowing can help to restore some degree of fertility of the soils. It is where you have a lot of salt in your soil, and what happens is the salt comes to the top layer of the prisms to disperse and sort of round off, and you end up with what's called columnar structure. The next structure is block structure. In block structure, the structural units are block-like or polyhedral. They are bounded by flat or slightly rounded surfaces that are caused of the faces of surrounding beds. Typically, block structure units are nearly equidimensional but grade to prism and to plates. There are two types of block structure. The structure is described as angular blocky if the faces intersect at relatively sharp angles. A subangular blocky if the faces are mixture of round and plane spaces and the corners are mostly rounded. Block structures are common in subsoil but also occur in surface soil that have a high clay content. The strongest block structure is formed as a result of swelling and shrinking of clay minerals which produce cracks. Sometimes, the surface of dried up sloughs and ponds show characteristics cracking and peeling due to clays. The next structure is granular structure. In granular structure, the structure units are approximately spherical or polyhedral and are bounded by curved or very irregular faces that are not cast of adjoining beds. In other words, they look like cookie crumbs. Granular structure is common in the surface of the soil of rich grasslands and highly amended garden soils with high organic matter content. Soil mineral particles are both separated and bridged by organic matter breakdown products, and soil biota exudates, making the soil easy to work. Cultivation, earthworms, frost action, and rodents mix the soil and decreases the size of the beds. This structure allows for good porosity and easy movement of air and water. This combination of ease in tillage and good moisture and air handling capabilities and good structure for planting and germination are definitive of the phrase good tilled. It's these fine particles which are actually stuck together by organic matter. It gives you good granular structure. So the more organic matter that you have, the better your granular structure will be. And that's the 5 soil structure. Moving forwards, let Christian Trinidad discuss the world pattern of the soil.
Due to variations in soil texture, pH values, color, structure, and consistency, a variety of soils occur in the world. On the basis of maturity, these soils can be classified into 3 broad groups: zonal soils, azonal soils, and intrazonal soils. Zonal soils are soils which are fully mature and have well-developed profile. These soils reflect the influence of the regional climate and the vegetation that grows there. Azonal soils are soils of recent age and are not mature. These soils don't have a developed profile. They have not undergone climatic and biological action for longer duration, unlike the zonal soils. Azonal soils are poorly developed soils.
So what is cation exchange capacity? The cation exchange capacity of a soil is its capacity to exchange cations between the soil particles and the soil solution. So the cation exchange capacity is the sum of the total of exchangeable ions that a soil can absorb. Similarly, it is also used to describe the ability of a soil to hold ions. There are these five most abundant exchangeable cations in the soil, which are calcium, magnesium, potassium, sodium, and aluminum.
Okay. So guys, now let's move on to the first example of cation exchange capacity. So the given problem is, what is the cation exchange capacity of the soil sample given the data in table? So now let's proceed in determining our given. So first we have calcium squared with a concentration number of 7.00 centimoles of charge, followed by magnesium squared with a concentration number of 6.00 centimoles of charge, followed by potassium with a concentration number of 2.00 centimoles of charge, followed by hydrogen with a concentration number of 5.00 centimoles of charge, and lastly, we have aluminum with a concentration number of 31.0 centimoles of charge. So after knowing and getting our given, we are going to determine our solution. Our solution that we are going to use to solve this problem is cation exchange capacity is equals to calcium squared plus magnesium squared plus potassium plus sodium plus hydrogen plus aluminum. So yan guys, after knowing the solution and knowing the given, all we have to do is to substitute based dun sa value ng mga given natin. So yung next step natin is, di ba, magsasubstitute. So for calcium, we are going to use 7.00. For magnesium squared, we are going to use 6.00. For potassium, we are going to use 2.00. And for sodium, as you can see guys, yung sodium, hindi siya part nung data na given dun sa table. So we are going to do is, we are going to cancel it out because yung magiging value lang nito is 0. Next one is hydrogen with the value of 5.00 and aluminum with the value of 31.00. So after natin mag-substitute, all we have to do is to add those values and we are going to come up with an answer of 51 centimoles of charge. And then after that guys, if we are going to go back dun sa unang table, makikita natin na yung first example nakapaloob siya dun sa soil competent na marmoleate clay and smectite clay because yung 200 and yung 150 is greater than 51 and then yung 30 below is less than 51. That is why dun nakapaloob yung ating first example.
Dito po tayo sa example number 2. What is the percent-based rotation? Percent-based rotation is the percentage of the CE occupied by the basic cations of calcium with the base of 2 positive, magnesium with the base of 2 positive, and potassium positive. Yung percent-based rotation daw, yun yung percentage ng CE. Ano nga ba yung CEC? Yung CEC yun yung cation exchange capacity. Ito yung kabuuan ng soil na nagawak ng exchangeable cation. Ito, yung CEC din, yun yung nag-influence sa soil na nagawak din ng mga nutrients at saka nagpo-provide din ito ng soil acidification. So, may problem tayo dito. Tsaka ano nga ba yung formula ng ng base rotation? So, ito yung formula ng percent-based rotation. Ca with the base of 2 positive plus magnesium with the base of 2 positive plus potassium positive plus Na sodium plus times 100. So, paano nga ba sinusolve yung percent-based rotation? To calculate the percent-based rotation, divide the sum of the given then multiply it by the 100%. Yung una, i-add mo muna yung mga sum ng mga given, tapos yung resulta, i-multiply mo to sa 100%. So, ito yung given. CA squared plus MG squared plus K plus positive plus NA plus positive times 100 over CEC. So, para makuha natin to, i-convert lang natin to sa given sa chart. So, ano nga ba is calcium with the base of 2? So, yun yung 7.00. Yun yung nakalagay sa chart natin. Susundan lang natin yung chart natin. Plus 6.00 plus 2.00 plus 0 times 100 over 51. Saan natin nakuha yung 51? Yun yung 51 nakuha natin yung sa example number 1. So, proceed na tayo. I-add lang natin to, itong 4, magiging 15. Rewrite lang natin yung times 100 tsaka yung 51 over 51. So, ito times lang natin yung 15 sa 100. Makukuha natin 1,500. Rewrite lang natin ulit yung over 51. So, dito, nakuha natin 1,500 over 51. I-divide lang natin to, makukuha natin na sagot ay 29.41.
Next ay kunin naman natin yung saturation ng magnesium 2 positive. Nakita naman natin doon sa table na yung concentration ng magnesium is 6.00 and yung CEC natin is 51. I-divide natin yung 6 sa 51 then times 100, makukuha natin ay 11.76%.
For our last example on cation exchange capacity, we have this problem. For a soil consisting of 2% organic matter and 20% Montmorillonite clay, estimate the cation exchange capacity. For this problem, we are given the percentages of two soil components. These are 2% organic matter and 20% Montmorillonite clay. We are required to find the sum total of exchangeable ions that this soil can absorb, or its CEC. To find its total CEC, first, we need to solve the CEC of each individual soil components. For the organic matter, we multiply 2%, which is 2 over 100, by 200, which is the approximate CEC of organic matter, and we will get 4. Next, for the Montmorillonite clay, we multiply 20%, which is 220 by 100, which is the approximate CEC of Montmorillonite clay, and we will get 20. After solving the CEC of each individual soil components, we need to get its sum to know the total CEC. So, 4 plus 20 would give us the answer 24. So, this soil has a cation exchange capacity of 24 centimoles of charge per kilogram.
Hello guys, I'm Marwin Sumang and I am here to discuss the sample solution number 1. Sample solution number 1. What is the estimated EC or electric conductivity of solution that has 1 milliequivalent per liter of sodium ion, 3 milliequivalent per liter of potassium ion, 3 milliequivalent per liter of bicarbonate ion, and 4 milliequivalent per liter of calcium ion? In this sample question, the missing value that we are going to find is the EC or the electric conductivity. In order to get the answers, we need to use this formula. Cations plus anions is equal to EC multiplied by 10. First, we need to gather all the given in the problem. These are the 1, 3, 3, and 4. In the formula, you need to add all the cations and the anions. And that is 1 plus 3 plus 3 plus 4 is equals to EC multiplied by 10. And we will get the answer of 11 is equals to EC multiplied by 10. Since the missing value is the electric conductivity, we need to divide both sides by 10 in order to cancel the 10. The last step is divide 11 by 10 and we get 1.1. Therefore, in the problem, the electric conductivity that is missing is equivalent to 1.1 decisilmens. And here is John Emil Torres for the next sample question.
Hi, I'm John Emil D. Torres, and I'm here to discuss the sample number 2. If total dissolved solid are calculated as 250 mg per liter, what is likely value for electrical conductivity in a solution dominated by calcium ion salt? So in this problem, we need to find the easy solution dominated by calcium ion salt. So we will use the formula total dissolved solid is equal to electrical conductivity times 800, which is the calcium ion is dominated. And the TDS is given. It is 250 mg per liter and is equal to electrical conductivity times 800. But the problem are, the EC is needed. So we need to cancel the 800 by divided by it both sides. So the remaining are EC is equal to 250 over 800. And 250 divided by 800 is 0.3125. And the electrical conductivity of the calcium ion salt is 0.3125 decimens per meter.
Okay. And that's for today's video, guys. I hope you learned something for today's stream. And before ending this stream, guys, let me leave this very motivational quotation from you by Dr. Charles E. Kellogg. All life depends upon the soil. There can be no life without soil, and no soil without life. They have evolved together. That's it, guys. I hope you learned something kahit papaano. And I hope na this pandemic you are all doing alright. And stay safe, guys. Take care of yourself. Drink water and stay happy. See you on my next stream, guys. Take care and good luck.